Hello, today I'm going to talk about how you can solve non-homogeneous differential equations using something called the variation of parameters. So the best way to show you is with an example and then explain it. So if we have the non-homogeneous differential equation y double prime minus 4y prime plus 4y equals e to the negative 2t natural log of t. This is non-homogeneous because this part is not 0. If this part right here was 0, this would essentially just be an algebra problem. It's really simple. Because that is not equal to 0, it is a little more complex. So for variation of parameters, there are really two steps. The first thing you do is you pretend it's homogeneous. So we'll just say that the part over there on the right is 0. And then you get your 2 or plus solutions from the homogeneous equation. So if this part was 0, you could just do an auxiliary equation for this. Turn each of these into a variable, so that'd be r squared minus 4r plus 4 equals 0, blah blah blah. And you solve for y1 and y2. And then your second step is you use a system to solve for function coefficients. And what those are Okay. A general solution, if it's homogeneous, the general solution is, y of t or any variable equals c1e to the at or whatnot, where this is your root, so you could say rt. But because this isn't homogeneous, we have a different general solution, and that's going to be y of t equals v1 y1 plus v2 y2 ... where the y's are these solutions from your homogeneous, and the v's are these coefficients to these solutions that we have that are actually functions themselves. So really the goal right now is to find those v's. And what we can do is use this system of equations. So once we have your homogeneous solutions, if we use this system, v1 prime, make sure you remember that this is a prime. So v1 prime of t times your first solution plus v2 prime of t times your second solution can equal 0. And you can notice that because these are prime, and in the general solution they're not, there's going to be some integration involved later. So that's your first equation in your system of equations. There's two variables, so the second equation you can use is v1 prime of t. That's not any different. But now you have times the derivative of your general equation, your general solutions to the homogeneous, plus v2 prime of t, unchanged, times the derivative of your second solution. It's going to equal f over a. Okay, so what f is, it is the part that makes your equation non-homogeneous. So that would be this part, that's f. And a is just going to be the coefficient to the highest powered term, or the highest derivative powered term. So right here, a is 1. If this was 2y, blah blah blah, then a would be 2. So that's 1. So f over a in this case is just this part over 1, which is just this part. So we're going to say f over a is going to be equal to e to the negative 2t natural log of t over 1. So yeah. So let's actually do this problem really quickly. So first thing we need to do is solve for the homogeneous solutions. Here's the auxiliary equation. We just pretend this part is 0. So we say that the equation is y double prime minus 4y prime plus 4y equals 0. Alright, so our auxiliary equation would be r squared minus 4r plus 4 equals 0. I always mess this up whenever I just do the simple method of saying what multiplies to that and adds to that. So I'm just going to quickly do the quadratic formula to make sure I'm right. That's negative b plus or minus the square root of b squared minus 4ac all over 2a. So what we see is our answer is just 2 because this part goes to 0, but that's a double root. So what happens when you get a double root? Your solutions to the homogeneous equation will be c1 e to the rt, right, plus c2 times t e to the rt. If this was a triple root, if you could break this up into r minus 2 times r minus 2 times r minus 2, so you have that 3 times. You just keep adding a t, so the next one would be plus c3t squared, then c4t cubed, depending on how many roots there are. So for us it's just a c1 e to the 2t plus c2 t e to the 2t. That's just from the homogeneous part, and you should know that by now if you're doing this. Okay, so our two solutions, we can just ignore the c's, they don't matter. So y1 we'll say is e to the 2t, and y2 is going to be t e to the 2t. Alright, so now let's plug this into those systems, the equations of the system, and let's solve for the variable coefficients so that we can get our general solution right here. Okay, so let's plug things in. Okay, so if we plug things in, we get v1 prime of t, that's unchanged. Let's plug in y1 of t, that's going to be times e to the 2t. Okay, plus v2 prime of t, hasn't changed, we're still solving for that. Times y2 of t, that's our second part of the general solution for the homogeneous part. That's times e to the t times e to the 2t. It's going to equal 0. And our second one, if you look here, for the second equation, we need the derivatives of these two parts. So let's take these derivatives. So y1 of t equals e to the 2t. That derivative is going to be 2e to the 2t. For the second one, t times e to the 2t. We need to do the product rule. So that's first times derivative of the second plus second times derivative of the first, which is just 1. So this part's just, I'll just rewrite it, 2t e to the 2t plus e to the 2t. You can pull out the e to the 2t, it doesn't really matter. Okay, so those are our two derivatives for these parts. So let's put that in our second line. So we have v1 prime of t times 2e to the 2t plus the second v2 prime of t, which is the second function coefficient, times the derivative of our second solution to the homogeneous equation. So that's 2t e to the 2t plus e to the 2t. It's going to be equal to e to the 2t, which I'll get t. You may have noticed something if you're attentive or you've done this before, but on our second equation, in our system of equations, we can pull out e to the 2t out of everything, literally everything, and I just noticed I wrote negative 2t. Oops. We can pull out e to the 2t from everything, and essentially when we do this, you'll be able to see that in the beginning of the question, on the function part, there's usually going to be something here that resembles your second system, your second equation in your system, which is great because now we can kill it out of everything. So I'm going to assume you can do the system because it's slightly tedious and annoying. You just need to really do these steps. You should have no problem. Using the first equation, let's say this is 1, 2. Using equation number 1, you can solve for either v1 prime of t or v2 prime of t. Okay, so in this case, let's do that right now. So let's say we're solving for v1 prime of t. We'll subtract this to the other side, divide it by this, which cancels out with this, if you can imagine that. So v1 prime of t in this case would equal negative v2 prime of t times t. Okay, and then you can plug that into this equation. So if you plug that in for v1 prime of t here, we'll have negative v2 prime of t times t. And now we can solve this equation for v2 prime of t because it's one equation and one variable. So the next step, when you have v1 prime of t or v2 prime of t equal to something, integrate it. Let's say it's v1 prime of t to get the non-prime version, the integral of it, because you'll need that for your general equation, right? If you remember up here, the general equation, that's not prime, so you just need the integral of it. And then once you've solved for either v1 prime of t or v2 prime of t completely, you can plug it back in to the first equation and solve for the other and integrate. So you just plug it in, solve for the other one, you'll have one equation, one variable. And then you integrate that one because that one's also going to be prime. Say that'll be this, and you'll get v2 of t. And then that's literally it. And then after that, you just plug that in here. You put whatever you got for v1 here, whatever you got for v2 here, multiply them by your solutions to the homogeneous equation. Don't worry about constants in this case. You could put it, it doesn't really matter. In fact, most people won't put it. And essentially, that's it. The big thing to keep in mind is you have to do this system, which looks complex, and it's really not, it's just annoying. And once you do Laplace transforms, I made a video on that, this becomes absolutely useless and you'll never need to look at it again. Alright, thank you.